So in this lesson, we're going to delve a little deeper into a concept that we've mentioned several times, which is separation of variables. Okay? When we're dealing with differential equations, we've looked at things like this, where before we want to integrate, we're actually going to put everything that has an x with it on one side and everything that has a y with it on the other side, and then integrate. Okay? So for example, in this case here, we have x squared plus 4 dy dx equals x times y, and we want to find a general solution for y. Now, when you're doing this, obviously we don't want dy dx in the answer for what y is, because if you don't know what y is, you can't know what the derivative is. So this is why we have to go ahead and separate the variables. And in this case, what I would do, I need this dx to be in the numerator, so I'm going to multiply by a dx, and I've got xy dx equals x squared plus 4 dy. And now I've got to get the x squared plus 4 on the other side, and I've got to get the y over on the left side. This is kind of like, remember doing implicit differentiation, where everything that had the y prime you get on one side and get all the other stuff on the other? Kind of a similar concept. Just get everything with a y on one side, get everything with an x on the other side. So I'm going to have 1 over y dy equals x over x squared plus 4 dx on the other side.
So we're just doing algebra pretty much.
You're just doing algebra at this point, yeah. Once you have it at this point, then we can do the integration. Okay? Now we can do the integration. The integral of 1 over y dy is ln of y. Okay? And over here, u substitution, the u equals
x squared plus 4.
good, and du 2x dx. Alright, so we need a 2 here and a half outside. So 1/2, the integral of du over u is ln absolute value of u. So this is ln absolute value of x squared plus 4, which is always positive anyways, so I can just make it the ln of x squared plus 4. And then we will have a plus c in there. Okay? And I'll call that c1.
It's going to end up changing, right?
Okay? It is going to end up changing because we've got to solve for y, right? So we're going to solve for y by taking and putting these as the exponents of e on both sides. Okay? So now we have y equals e to this. And we've done this a few times, so let's look at this. We've got e to the c sub 1 times e to the 1/2 ln of x squared plus 4.
Can you bring that up first?
Yeah, let's bring that half inside, so it's e to the ln of radical x squared plus 4, because I brought the half in as a half power. And now that cancels out, and we have y equals a constant times radical x squared plus 4. And that would be our general solution for y. Okay?
Do we have like a changing of c here? No.
Changing of c.
Yeah, because you label it c1.
Yeah, you know, I label it C1 at the beginning, and actually in Calc Chat you'll see that they don't actually do that. This isn't a matter of right and wrong, it's just a matter of making sure that you're demonstrating your thinking properly. Okay? We're recognizing that this constant up here is not the same constant we end up with. Because the constant we end up with is actually e to this power. You know, that will be helpful if you were asked to find a particular solution and you're given some point to plug in. You would not want to plug it in back here, get this C and then put it right here. Okay? You would want to plug it in at the end and find the actual C that you see in the final equation. Okay? Joey?
If you didn't move the 1/2, can you do that and you change, like we changed that addition to multiplication, can we leave the 1/2 and do e to the 1/2 plus?
It wouldn't be e to the 1/2 plus because they're multiplied here, right here. It would be e to the 1/2 to the ln power, or you could make it e to the ln power to the 1/2 because you're multiplying exponents. But, you're right?
Is it a little, it's not off topic, but that square root of x squared plus 4, couldn't you technically write that as a constant? Because when you're plugging in something, it's gonna end up being a constant, or like,
Well, anytime you plug in something, it will be a constant, but we're
I'm
not,
talking about for this situation.
we need the variable, we need x in there, yeah.
So like
Now here's an example of finding a particular solution. You'll notice this one actually doesn't have a y prime in it. It already has the dy's and dx's pulled apart. We've just got to work out how to get this all arranged properly, okay? So the first thing that I would do here is go ahead and subtract the xy dx from both sides. That'll get these, at least the dx and the dy on opposite sides of the equation. So we have e to the negative x squared times y squared minus 1 dy, and that equals a negative xy dy, or sorry, dx. Now I've got to get the e to the negative x squared over to the other side. And I've got to get the y on the right over to the left side. So I'm going to divide by the y. I'm actually, and this is where you can kind of save yourself a little bit of work. I'm going to multiply by e to the positive x squared. Because that's the reciprocal, right? So I'm going to multiply by e to the positive x squared over here. That will cancel that out. This will cancel out the y, and notice what I end up with left here. I have y squared minus 1 over y dy, and over here I have negative x e to the x squared dx.
Oh, so you're saying rather than dividing the e to the negative x squared, we're going to bring it back.
Yeah, you'd end up having to bring it up anyways, so
Okay.
look for that opportunity to save yourself a step. Okay? So at this point then, we're going to go ahead and integrate. Because all the y's are on the left, all the x's are on the right. Both of these have kind of a extra element in the integration. On the right we've got e to the u. So to do the du, I need a positive 2x dx. So I'm going to make this a positive 2, which means I have a negative 1/2 on the outside. Okay?
Could you not do, if you did chain or product rule, would you get the same thing? Or would you not do?
Well, remember, there's no product rule in integration. So we have negative 1/2. The integral of e to the u is e to the u. So now it's just e to the x squared, and we'll throw our plus c on this side. Okay? On the right hand side, don't forget you can separate, since the denominator is a monomial, we're going to separate that into y squared over y, which is just y. So the integral of y squared over y is y squared over 2. And then the other one is a minus 1 over y. So minus the integral of 1 over y is ln of y.
That's because you can't do u in the numerator, right? Or can you?
Yeah, well, couple of reasons. Yeah, the u, I mean, it's not that you can't, but it's just, you wouldn't be able to get your du. If you made the numerator the u, then du would be 2y dy. We have a 1 over y as the other part of our function, so. Okay, so now we need a particular solution, okay? We have the initial condition y of 0 equals 1. Okay, so let's see what we have. Let's see what we can do with this here. I'm going to multiply everything. This would be absolute value. I'm going to go ahead and multiply everything by 2 first of all. So I'm going to have a y squared minus 2 ln absolute value of y, which the nice thing about multiplying by 2 here is that I now can get rid of the absolute value because now I have ln of y squared. Okay? And then I have a minus e to the x squared plus 2 times c1, which is just some other constant. So I'll call it c2. Okay? Now, at this point, we're at a point where actually getting y equals is not possible because this is not a function. Okay? This is, this is some kind of a relation here, but when you have that y squared in there, you're dealing with something that's not a function. So that's where you don't necessarily have to get it all the way down to y equals something, but we should go ahead and figure out what our constant is. And we can do that by plugging in the 0 for x. So we have e to the negative e to the 0. And we plug in a 1 for y. So 1 squared minus ln of 1. Ln of 1 is 0. So this constant is 1 plus 1, so 2.
You know, like we have the two constants, C1 and C2. And C2 is just 2 times C1.
Mm-hmm.
You know, like with your point to plug it into the first one and the second, because the only difference in the two is the constant.
Well, the difference in the two is that the first one, or the second one, we had multiplied both sides of the equation by 2.
Yeah.
So, I mean, in the end, it doesn't matter as long as you recognize that when I get 2 here, that's not the same thing as what that C1 was up there. The C1 would have ended up giving us a 1. Okay? So anyways, the final solution here would be y squared minus ln of y squared equals negative e to the x squared plus 2.
Not very satisfying.
Okay? You could play around with things a little bit and try to do something, but there's really not a whole lot you can do with that. Okay? So let's look at one more example here. Finding a particular solution curve. Alright, it says find an equation of the curve that passes through the point 1, 3 and has a slope of y over x squared at any point xy. So this is really just another way of asking you to do the same thing we were doing on the last problem. It's just a different way. We have a slope of y over x squared. What does that mean? Yeah, y prime dy dx is y over x squared. if we want to make sure it passes through 1, 3, that means we're finding a particular solution. Okay? So that's all we're doing here. And now we separate the variables, 1 over y dy, divide both sides by y, multiply both sides by a dx, and we've got x to the negative 2 dx. And now we're just integrating, okay? ln absolute value of y equals x to the negative 1 over negative 1, so negative x to the negative 1, plus some constant. Now this one we can solve for just y. If we take this and make these the exponents of e on both sides, that's going to give us y equals e to the negative 1 over x power times e to the c1 power, which I'll go ahead and call, oops, I'll go ahead and call C2, or we can actually just call it C because there's nothing else to do algebraically here. Okay? So that's a general solution for a function that will have a derivative equal to y over x squared. Now I want it to hit the point 1, 3, so I'm plugging in 1 for x, so it's c times e to the negative 1 over 1 equals 3. Okay? So that's e to the negative 1, or c over e, equals 3. So c is 3e. Okay? And that means y is 3e times e to the negative 1 over x. Yep.
Could you have done it by saying, like, rather than doing the dy dx equals y over x squared, doing y minus 3 equals y over x squared times x minus 1, and then do it that way, and then solve for y?
So you're talking about the slope of the tangent line?
Yeah, like do it.
You're getting the equation of a tangent line.
And then solving for the y.
I'd have to run through that and see. Okay. By the way, you guys see we can simplify this last answer just a little bit more? What would that be?
3e to the negative 1 over x plus 1.
E to the what power?
Negative 1 over x plus 1.
Yeah, negative 1 over x plus 1, or 1 minus 1 over x. Just to get a really nice answer there.
It's like a safe base.
That would work.